Hello, this is part one of a two-part series on similarity and congruence. Okay. So first of all, as we get into similarity, we have to understand the topic of scale factor. Okay, so scale factor is what you multiply the original by to get the new. Okay. Some important things is if you multiply by a number bigger than 1, you get bigger. If you multiply by a number smaller than 1, like 0.5, 0.6, 0.3, 0.1, okay, a decimal, usually a fraction of 1, you get smaller. And the special one is if you want to stay the same, you have to multiply by 1. Okay, you can multiply anything by 1 and you'll end up staying the same. Okay, so here's our original figure. And if I have a scale factor of 3, I'd multiply all the sides by 3. 3 times 3 is 9, and 2 times 3 is 6. If I had a scale factor of 1/2, okay, half is smaller than 1, so we know it's going to shrink. It's going to get smaller. Half of 3 is 1.5, and half of 2 is 1. So notice it gets smaller when I have a scale factor of 1/2, and it gets bigger when I have a scale factor of 3. Okay, so now to the main theme, similar shapes. So these two rules are good for all shapes whatsoever. Okay, so anything that's a shape that's similar has to have congruent angles, meaning that the angles are the same, and proportional sides. Okay, proportional is the reason why we talked about scale factor before, is because proportional means that it has a constant scale factor. All the sides of the shape have the same scale factor. It's consistent. Okay. So notice I have a small side, a medium side, and a large side. And then to get the new shape, we have a small times the scale factor, a medium times that same scale factor, and then a large times the same scale factor again. If we look at the angles, this small angle matches that small angle, this large angle matches this large angle, and this medium angle matches this medium angle over here. Okay. You'll notice I color coded according to that side angle relationship, which we'll get into shortly. Okay, so that was the general definition for any shape. This lesson now is going into specifically triangles. Okay, so these shortcuts only work for triangles. The nice thing is that every shape is made up out of a bunch of triangles, so it's helpful. Circles are the one shape that people have a hard time with, but if you throw in an infinite amount of triangles in there, you can start seeing how this could be helpful. Okay, so the two methods is actually you just cut it in half. So instead of having to show that all three angles are the same and that all three sides are proportional, you can actually just do one for a triangle and it proves the other. It guarantees the other thing's going to happen. Okay, so the rule is if all three corresponding angles are congruent, then all three corresponding sides are proportional. Okay, so all you need to know is that the three angles match and then your shapes are similar for triangles. Okay. Likewise, if you know all three sides are proportional, then all three corresponding angles are going to be congruent. Okay, so once again, this means that if you have three corresponding sides for a triangle that are proportional, then these triangles are similar. Okay, once again, this only works for triangles. So if you want to use this, you have to cut your shape into triangles, not squares or rectangles or other things. Okay, all right. So for two examples, we're going to demonstrate one of each type. One's the all three angles match. Okay, so what you have to do here is note the rule. The rule is if all three corresponding angles are the same, congruent, then we also know that the three sides will be proportional, and that satisfies the definition for similarity. Okay, on the right, I have the evidence over here, and you're expected to show the evidence to support your reasoning. Okay, so for angle, 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 similarity, this tilde means similarity, we must give evidence of three congruent angles. Okay, I color coded them here for you guys. Hopefully that's helpful. The 50 matches the 50, that's our angle 1. The 60 matches the 60, that is our angle 2. And the 70 matches the 70, that's our angle 3. Okay, that's it. Nothing too crazy. You just got to show, yes, that matches, yes, that matches, yes, that matches. We have 3 of them. Okay, and that is called angle, angle, angle similarity. Okay, that tells us that the three sides must be proportional, and overall, these two triangles are now similar. We can say that. Okay, so second example. You guessed it, side, side, side. So just showing the other half. So if three sides are proportional, then we know that the angles inside have to be congruent. And then that means that the shapes, these triangles, will be similar. Okay, so for side, side, side similarity, we must show evidence of three proportional sides. The way you do that is you write down the sides you have. So we have a 5 that corresponds with a 15. Okay, 5 times 3 is 15. A 7 times 3 is a 21. And then a 10 times 3 is a 30. Okay, so every side here has the same scale factor, and so we know that they are proportional. This proves us that these two shapes are similar because of the side, side, side proportional relationship. Okay, cool. So the next slide is extra credit. This is for those students that are wanting to get an A or B in the class. The previous two are required for everyone. Okay, if you're just worried about getting credit, those are the two you need to know. Okay, the third one, though, is separate. Okay, so it's not like an extension of side, 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 and angle, angle, angle. It's this idea that if you have two sides and the angle in between them, then the third side is stuck in place. Okay, so I encourage you to check that out and play with some shapes and stick an angle in between them, and then you'll realize that there's only one possible distance for that third side, and that's what this is based off of. Okay, so the rule is if two corresponding sides are proportional and the angle in between them is congruent, then we can say that these triangles are similar. Okay, to give the proof for that, we need to show two proportional sides and an angle in the middle that's congruent. Okay, so side 1, I'm choosing the red one to be side 1. 5 times 3 is 15. And then 7 times 3 is 21. And the angle between, in both cases, is the same. They're both 70. So I'm showing everything that's required to prove the congruence, okay? Or the similarity, sorry, in this case. Because they're not congruent, we have a scale factor of 3, meaning it's getting bigger. It's not the same, okay? Scale factor for congruence would have to be 1. Okay. So the evidence above is called angle side angle. Okay, because this angle, the 70 is in between the two sides that they gave us, and the two sides are proportional in each triangle. Okay, that means that these shapes are indeed going to be similar. Okay, once again, similar means that the sides are proportional, the angles are the same. So that's what we know about these two triangles. Even though we don't know what this large side is, or this large side over here, we know that whatever this is going to be multiplied by the same scale factor. In this case, it's 3 to get this one over here.